You will consume over 60 tons of food in your lifetime, yet your own human cells cannot digest most of it. Instead, 38 trillion microbial hitchhikers living inside your colon hijack every meal you eat, transforming daily bites into active chemical hormones. Take Mark, a 42-year-old spending $400 monthly on organic groceries, yet still struggling with stubborn belly fat. Mark's problem is not his total calorie intake, it is a hidden enzymatic deficit in his gut that we will decode in 3 specific steps today. If you want the real science behind longevity and human metabolism, subscribe to the channel right now and let's get into it. Most people assume human digestion is merely mechanical blending, but your gut microbiota actually operates as a highly active 3-pound endocrine organ. When you swallow a raw apple, stomach acid destroys surface bacteria, but resistant dietary fiber survives unscathed all the way down to your colon. Think of your colon as a dark fermentation bioreactor where specialized bacterial species like Bifidobacteria act as microscopic chemical engineers working around the clock. These microbial engineers ferment complex polysaccharides that would otherwise pass through you as useless waste, generating potent metabolic byproducts in the process. Their main chemical output is a short-chain fatty acid called butyrate, which serves as the exclusive energy source for your colon lining. Without adequate butyrate production, your intestinal wall loses its structural integrity, creating microscopic physical gaps that leak bacterial endotoxins directly into your bloodstream. That exact microbial leakage explains why Mark felt perpetually exhausted every afternoon, despite eating large bowls of organic spinach salad for lunch daily. Raw spinach is loaded with oxalic acid, an aggressive plant defensive toxin that binds to minerals and tears up unprotected intestinal epithelial cells. Only one specific gut bacterium called Oxalobacter formigenes possesses the specialized enzymatic machinery required to safely neutralize those dangerous oxalate crystals before they cause harm. Because Mark took 2 rounds of broad-spectrum antibiotics 5 years ago, he completely eradicated his personal colony of those oxalate-destroying microbes. Yet fiber is only half the equation. What your gut bugs do with dietary protein is far more toxic when your digestion is compromised. When excess animal protein escapes absorption in the small intestine, it enters the colon and undergoes microbial putrefaction instead of healthy fermentation. Bacterial decay of undigested amino acids generates phenylacetic acid and P-cresol, inflammatory chemical metabolites that directly burden your liver filtration capacity. Imagine leaving raw steak inside a warm 85-degree incubator for 48 hours. That exact chemical decay occurs inside a sluggish bowel. Those putrefactive toxins absorb into intestinal capillaries, traveling straight to your pancreas where they disrupt cellular insulin signaling within just 3 hours. This mechanism explains why Mark's fasting blood glucose remains stubbornly elevated at 115 milligrams, even while practicing strict low-carb keto. His high-fat diet inadvertently fed an overgrowth of firmicutes, a specialized phylum of bacteria notorious for extracting maximum calories from swallowed food. Firmicutes produce unique microbial enzymes called glycoside hydrolases that strip extra energy from indigestible plant cell walls, forcing your body to store fat. 2 people can eat the exact same 2,000 calorie meal, yet the person with firmicutes dominance absorbs 150 more calories daily. That hidden microbial absorption discrepancy translates to 15 pounds of unexplained fat gain over a single year without eating 1 extra bite of food. To reverse this caloric hoarding, you must stop counting macronutrients and start feeding your microbes their favorite biochemical signaling molecules called polyphenols. Found abundantly in dark berries and green tea, polyphenols act as selective microbial antibiotics, destroying harmful firmicutes while nourishing beneficial Akkermansia mucinifera. Akkermansia is your master metabolic regulator, residing within the mucus layer and constantly thickening your protective gut barrier against systemic bloodstream inflammation. Think of Akkermansia as a dedicated master mason constantly applying fresh brick and mortar to keep your intestinal fortress completely sealed and secure. But even if you consume abundant polyphenols daily, a common household beverage is likely destroying your Akkermansia colonies before they can even replicate. As those undigested plant fibers drop into your colon, over 38 trillion microbes are waiting like a factory shift ready to work. Unlike your basic human stomach enzymes, these gut bacteria possess over 40,000 specialized genes dedicated solely to cracking complex carbohydrates apart. Think of raw plant polyphenols and resistant starch as locked treasure chests that only specific microbial enzymes can actually open for you. When beneficial species like Bifidobacteria feast on those dietary fibers, they trigger a rapid anaerobic fermentation process that generates powerful metabolic byproducts. We call these byproducts short-chain fatty acids, specifically acetate, propionate, and butyrate, which serve as your body's primary biochemical messengers. In fact, butyrate is the ultimate VIP here, providing roughly 70% of the total cellular energy required by your colon wall. Imagine your intestinal cells as a high-security border patrol that relies on steady butyrate fuel to keep strict checkpoints tightly closed. Without enough of that essential bacterial fuel, those protective tight junction proteins physically shrink, leaving dangerous microscopic gaps between your gut lining cells. This structural collapse creates chronic intestinal permeability, commonly called leaky gut, allowing partially digested food particles and bacterial toxins to escape directly into your bloodstream. Once those stray molecules hit your blood circulation, the immune system treats them like invading foreign armies, triggering immediate and widespread systemic inflammation. But what actually happens when you follow a typical standard American diet consisting mostly of ultra-processed foods that contain zero dietary fiber? Starved of their primary plant nutrition, your surviving gut microbes suddenly face a desperate survival choice inside an entirely nutrient-depleted colon. In a shocking evolutionary adaptation, starving species like Akkermansia turn around and begin cannibalizing the protective glycoprotein mucus layer lining your gut. They literally eat your gut wall for breakfast, rapidly stripping away the delicate barrier shielding your living tissue from trillions of resident microbes. This relentless internal erosion triggers a silent, low-grade inflammatory fire that spreads through your circulation, accelerating biological aging and driving insulin resistance. Meanwhile, let us track exactly what happens to excess dietary proteins that escape upper digestion and enter this teeming lower bacterial ecosystem. When microbes ferment undigested amino acids instead of fiber, they switch from beneficial carbohydrate fermentation over to a destructive process called putrefaction. This putrefaction generates hazardous nitrogen byproducts like P-cresol, ammonia, and hydrogen sulfide, which is the exact chemical compound responsible for rotten egg odors. In high concentrations, these protein fermentation toxins directly damage your cellular DNA and significantly increase your long-term risk of developing colon cancer. But there is a fascinating dietary plot twist regarding how your gut flora handles dietary fats and cholesterol every time you eat. When you consume dietary fat, your liver secretes bile acids into the digestive tract to act just like biological dish soap emulsifying grease. Once those primary bile acids finally reach your colon, specific bacterial enzymes chemically transform them directly into powerful secondary bile acids. These secondary bile acids act as endocrine hormones, binding to specialized cellular receptors that regulate your thyroid output and metabolic burn rate. This explains why two people can eat the exact same 2,000 calorie meal, yet store completely different amounts of body fat. Your microbiome effectively dictates how many calories you absorb, harvesting up to 150 extra daily calories from food if imbalanced. Over a single year, that daily microbial calorie bonus translates to gaining more than 15 pounds of pure fat without eating extra food. Even more astonishing is what happens when your microbes metabolize antioxidant polyphenols found in colorful foods like blueberries, walnuts, and dark chocolate. Human cells cannot absorb most raw polyphenols. 90% reach your colon untouched, waiting for specific bacterial enzymes to activate their healing power. Microbes transform these complex plant compounds into bioactive metabolites like urolithin A, a potent molecule that triggers cellular rejuvenation across your entire body. Without the right bacterial strains in your gut, spending $200 a month on antioxidant superfoods is literally washing your money straight down the drain. By the time food reaches the end of your small intestine, human digestion is officially over, leaving behind tough, complex plant fibers.
Our human genome lacks the specialized enzymes required to cleave these intricate polysaccharide chains, rendering raw plant matter completely indigestible to us. But this leftover fiber is not biological waste.
It is the vital currency of your colon, where 38 trillion microbes eagerly await dinner. Welcome to the dark, oxygen-deprived environment of the large intestine, which functions just like a pressurized fermentation vat in a commercial brewery. In this strict anaerobic world, oxygen is actually toxic to your beneficial bacteria, forcing them to rely entirely on fermentation to survive. As these microbes feast on resistant starch and soluble fiber, they perform a collaborative chemical alchemy known to science as microbial cross-feeding. Primary degraders like bifidobacteria take the first bites of massive fiber chains, slicing them into smaller sugar fragments for their neighboring species. Next, secondary specialists swoop in to consume those loose fragments, converting them into powerful healing compounds called short-chain fatty acids, or SCFAs. Among these molecular treasures, 3 metabolic MVPs dominate your gut chemistry: acetate, propionate, and the undisputed king of gut longevity, butyrate. Butyrate acts as the primary biological fuel source, providing up to 70% of the total energy required by your colon's lining cells. Without steady butyrate from dietary fiber, these epithelial cells literally starve, causing the tight junctions between them to physically pull apart. When those protective cellular barriers open, bacterial endotoxins called lipopolysaccharides flood directly into your bloodstream, triggering systemic low-grade inflammation throughout your body. Your immune system treats these leaked endotoxins like a 5-alarm fire, silently driving up insulin resistance and stubborn visceral fat storage over time. Meanwhile, propionate travels straight through the portal vein to your liver, where it acts as a precise molecular brake on cholesterol synthesis. That same propolytracer signals liver cells to reduce glucose production, actively preventing those frustrating morning blood sugar spikes before breakfast. Acetate takes a different route, entering general circulation to cross the blood-brain barrier and directly stimulate your brain's hypothalamus to signal fullness. This is why a fiber-rich meal keeps you satiated for hours, while a $20 fast food lunch leaves you starving by mid-afternoon. But what actually happens when you switch to a zero-fiber American diet loaded with ultra-processed carbohydrates and refined industrial seed oils, starved of their primary plant fuel, your resident microbes get desperate and switch their nutritional enzymes to consume your own human tissue. They literally begin cannibalizing the protective glycoprotein mucin layer that coats and shields your delicate intestinal wall from stomach acids and pathogens. As this mucus barrier erodes from millimeter thickness down to bare tissue, opportunistic bacterial pathogens gain a permanent foothold in your gut. These invaders multiply rapidly, releasing gaseous metabolic byproducts that stretch your intestinal wall and cause severe chronic bloating after every meal. Worse, this microbial dysbiosis alters your bile acid metabolism, turning helpful digestive fluids into irritating detergents that trigger unpredictable chronic diarrhea. We used to blame this digestive distress on simple food sensitivities, but modern microbiome sequencing reveals a much deeper enzymatic breakdown. The real culprit is a dramatic loss of microbial diversity, like destroying a thriving rainforest until only stubborn invasive weeds survive. When you lose species richness, you lose the crucial genetic pathways required to unlock plant polyphenols and extract their potent antioxidant power. For example, without specific bacterial strains like Eggethella lenta, beneficial compounds from berries and walnuts pass through your digestive system completely wasted. You could spend $500 a month on organic superfoods, yet absorb zero metabolic benefits if your microbial extraction engines are missing. Even your daily coffee kick relies on this bacterial chemistry, as gut microbes metabolize chlorogenic acids into active anti-inflammatory compounds. This reveals a profound evolutionary truth. You are never just feeding a human body, but actively managing a complex bioreactor with every bite. While fiber gets all the attention, your gut microbes also completely rewire how your body processes dietary fat. It starts with the bile acids in your gallbladder. When you eat a ribeye steak, your liver pumps out primary bile acids like a biological detergent to emulsify those heavy lipids inside your small intestine. But roughly 5% of those bile acids escape reabsorption and drop straight down into the dark, oxygen-free microbial ecosystem of your lower colon. Here, specialized resident bacteria perform an ancient chemical transformation, stripping away amino acid chains to forge powerful secondary bile acids like deoxycholic acid. These newly forged molecules are never just leftover digestive waste. They act as potent metabolic hormones that circulate rapidly throughout your entire human bloodstream. They dock directly onto a specialized cellular receptor called TGR5, which functions like a master molecular ignition switch for your body's resting metabolic rate. Once activated by these unique microbial metabolites, this receptor triggers your brown adipose tissue to rapidly burn stored triglycerides and generate pure cellular heat. Meanwhile, a second receptor called FXR detects these metabolites to halt fat synthesis in your liver, actively protecting you against fatty liver disease. However, this microbial story turns darker when you consume excess dietary protein that your stomach and small intestine fail to fully digest upstairs. When those unabsorbed amino acids flood the colon, specialized proteolytic bacteria ferment them into highly inflammatory nitrogenous compounds like ammonia, P-cresol, and hydrogen sulfide. Take the amino acid tryptophan, certain microbes convert it into indole, which your liver transforms into indoxyl sulfate, a potent toxin that damages vascular endothelial cells. An even more insidious cardiovascular risk lurks inside the natural L-carnitine and choline found abundantly in everyday American foods like red meat and eggs. Specific gut bacteria feast on those dietary nutrients and release a volatile chemical gas called trimethylamine directly into your liver's portal vein circulation. Your liver immediately oxidizes that chemical gas into TMAO, a destructive compound that aggressively drives cholesterol deposition straight into your delicate arterial walls. Here is the fascinating clinical twist. If you feed a lifelong vegetarian a steak, their blood tests reveal virtually zero TMAO spike in the aftermath. Why? Because without a regular dietary supply of meat, their intestines completely lack the specific microbial strains required to perform that initial toxic conversion. Now let us examine another crucial nutritional category where your gut bacteria act as the ultimate biological gatekeepers for human health: plant polyphenols. You consume organic berries, coffee, and dark chocolate for antioxidants, yet over 90% of those complex molecules pass completely unabsorbed through your small intestine. In their raw botanical state, these polyphenols are bulky inert chemical structures that your human cells literally cannot absorb or utilize on their own. They must reach your lower colon, where specific microbial enzymes cleave their rigid chemical bonds to unlock smaller, highly bioactive compounds known as postbiotics. Consider the complex L-G-tannins found in walnuts and pomegranates. Select gut bacteria transform them into urolithin A, a remarkable compound that triggers cellular rejuvenation. This postbiotic metabolite enters your circulation and initiates mitophagy, a vital cellular recycling program that destroys aging defective mitochondria inside your muscle and brain tissues. Yet surprising clinical data reveals that only 40% of Americans harbor the specific microbial strains required to manufacture urolithin A from their daily diet. Without those specialized microbial partners in your gut, spending $50 on organic superfoods yields virtually none of their legendary cellular longevity benefits. This brings us to perhaps the most profound mechanism of all, how microbial food processing directly controls your brain's daily appetite and cravings. Lining your lower intestinal wall are specialized sensory units called enteroendocrine L cells, which function like internal taste buds constantly sampling your gut's microbial metabolites. When these intestinal sensory cells detect beneficial fatty acids and secondary bile acids, they immediately secrete powerful satiety hormones into circulation, including GLP-1 and PYY. These circulating hormones travel straight to the hypothalamus in your brain, slamming the brakes on hunger signals and producing deep-lasting physical fullness after meals. In fact, blockbuster weight loss drugs simply mimic the exact GLP-1 signaling molecules your gut microbiome naturally manufactures when fed the right dietary fibers. But what happens when modern factory-made foods completely bypass this microbial signaling system? The metabolic consequences are catastrophic for your weight and energy levels. Take Dave, a 42-year-old engineer spending $300 monthly on commercial probiotics while gaining stubborn belly fat. Why are these billions of live bacteria completely failing inside his gut? Most commercial probiotic capsules act like dropping grass seeds onto dry concrete. Without specific complex carbohydrates to feed them, foreign laboratory strains starve and vanish within 48 hours. What Dave actually lacks is Akkermansia muciniphila, a keystone species comprising nearly 5% of a healthy microbiome. Surprisingly, this crucial microbe does not consume dietary fiber at all. Instead, Akkermansia feeds directly on the mucin layer lining your intestinal walls. This constant pruning stimulates your goblet cells to regenerate a thicker, impenetrable mucosal barrier every single day. When Dave eats ultra-processed foods lacking polyphenols, his Akkermansia population crashes by 80%. This stripped barrier exposes his delicate intestinal wall to dangerous bacterial toxins called lipopolysaccharides. These lipopolysaccharides leak directly into his bloodstream, triggering metabolic endotoxemia. This silent, low-grade inflammation blocks insulin receptors in muscle tissue within just 3 hours of a typical fast food meal. Because those insulin receptors are blocked, Dave's pancreas must pump out triple the normal insulin. That massive hormone surge forces circulating blood glucose directly into stubborn visceral fat storage. Here is the contrarian truth. Standard fiber cannot rebuild this mucosal shield alone. You must consume specific polyphenols that act as direct growth signals for native gut microbes. Take L-glutathione found in walnuts and pomegranates. Your human digestive enzymes cannot break them down at all, leaving 95% completely intact as they reach your lower colon. Down in the colon, specialized bacteria transform those raw polyphenols into urolithin A. This powerful postbiotic molecule enters your bloodstream and directly stimulates cellular recycling inside your muscle mitochondria. But here is the catch, only 40% of Americans harbor the specific bacteria required to produce urolithin A. Without those microbes, expensive organic pomegranates pass through completely wasted. This explains why identical foods trigger wildly different metabolic responses. When Dave and his healthy colleague eat the exact same banana, Dave's blood glucose spikes 50 points higher. A landmark study of 800 people revealed that individual blood sugar spikes depend more on your microbial composition than on the carbohydrates printed on the food label. How can a gut microbe control blood glucose? Through the enzymatic conversion of dietary fiber into propionate, a specialized short-chain fatty acid that travels directly to your liver. Once inside the liver, propionate acts like a molecular brake pedal. It shuts down internal glucose production, dropping fasting blood sugar levels by up to 18% within weeks. Yet most Americans inadvertently starve these propionate factories. Cooking and immediately eating hot starches like rice or potatoes floods your bloodstream with rapid glucose before reaching the colon. But watch what happens when you cool that cooked rice in the refrigerator for 24 hours. The starch molecules recrystallize into a tight, impenetrable structure called resistant starch. Human enzymes cannot break this recrystallized matrix. It travels untouched to the colon, where bifidobacteria ferment it, slashing your subsequent meal's blood sugar spike by 50%. Even more incredible, you can reheat that cold rice without destroying the resistant starch matrix. This simple kitchen hack transforms a high glycemic food into premium microbiome fuel, but resistant starch is only half the equation. To truly reboot Dave's sluggish metabolism, we must leverage the biological miracle of microbial cross-feeding inside his digestive tract. No single bacterial species works alone. When bifidobacteria digest resistant starch, they excrete acetate as a biological waste product, which sounds trivial until you see what happens next. That discarded acetate is immediately scavenged by Faecalibacterium prosnitzii. This elite anti-inflammatory microbe uses the acetate as raw fuel to produce massive amounts of colon-healing biotrate. This biotrate binds to receptors on intestinal L cells, triggering a natural surge of GLP-1. That is the exact same satiety hormone mimicked by $1,000 weight loss injections. But when Dave takes a single course of broad-spectrum antibiotics, he decimates his Faecalibacterium populations. This chemical strike breaks the delicate cross-feeding assembly line overnight, halting natural GLP-1 production. To restart this stalled microbial assembly line rapidly, you need more than prebiotic fiber. You must consume live fermented foods to act as temporary biological scaffolding in your gut. A groundbreaking Stanford clinical trial proved that consuming 6 daily servings of fermented foods like kefir and kimchi slashed 19 different inflammatory blood markers in just 10 weeks. Surprisingly, those fermented microbes rarely take up permanent residence. They act like visiting architects, secreting antimicrobial peptides that kill pathogenic competitors and create space for native strains to thrive. This reveals the ultimate metabolic protocol for Dave, pairing cooled resistant starch with polyphenol-rich berries and fermented scaffolding to ignite explosive, synergistic microbial multiplication. Within just 14 days of this combined protocol, Dave's fasting insulin drops by 35%. His Akkermansia mucosal shield rebuilds thick enough to halt blood endotoxin leakage completely. But what happens when you introduce zero-calorie artificial sweeteners into this newly healed ecosystem? The chemical destruction that follows will completely change how you look at diet soda. What you put on your plate is only half the metabolic equation. Your gut bacteria run on a strict internal clock, and midnight snacks shut down their digestive engines. Give your gut a 12-hour overnight fast, and Akkermansia bacteria emerge like night shift janitors. They consume old mucus, forcing your cells to rebuild a bulletproof intestinal wall, but if you constantly graze, those janitors never clock in. Untreated cellular debris accumulates, leaving your mucosal lining paper thin and allowing bacterial toxins to flood your bloodstream. This reveals the ultimate metabolic shortcut, combining live fermented foods with targeted prebiotic fibers. Together they act as biochemical factories that pump out longevity molecules called postbiotics. Stanford researchers discovered that eating 4 daily servings of fermented foods, like sauerkraut or kefir, slashed systemic inflammation markers by 20% in just 10 weeks. Those ingested microbes rarely become permanent residents in your colon. Instead, they act like visiting drill sergeants, rapidly retraining your immune cells to stop attacking your tissues. Yet without plant diversity, that retrained army lacks ammunition. You need 30 different plant species each week to supply the complex polyphenols required for cellular repair. Think of your intestines as a customized internal pharmacy. Every walnut, lentil, and blueberry skin you swallow is a specific prescription filled by trillions of microscopic chemists. When fed correctly, these chemists manufacture compounds like urolithin A. This molecule travels to your muscles and brain, recycling old mitochondria to actively reverse cellular aging. That daily biochemical conversion explains why spending $20 a week on diverse produce outperforms any expensive synthetic longevity pills sitting on a pharmacy shelf. Ultimately, you are never dining alone. With every single bite, you are managing an ancient biological ecosystem that directly dictates your metabolism, your mood, and your lifespan. So the secret to metabolic longevity isn't starving yourself or fearing carbs. It is transforming your microbiome into a biochemical factory that continuously repairs your cells. Like if you value real science and comment your favorite fermented food below. Subscribe for more longevity tips and watch next how coffee transforms your metabolism.